Hi guys, so we're going to see how to graph this linear inequality that has x and y in it. And to do this, we need to already know how to graph a line or a linear equation. And if you're not sure or don't remember, you can see my video on graphing linear equations. So we're first going to find out if this were a line, where would it lie on the graph? And there's two different ways we could do this. We could solve for y, and then we would have mx plus b format. We would plot the y-intercept and then the slope. Or since we already have x and y on the same side, we can simply find the two intercepts, and then we'll have 2 points, and then we can make our line. So we're first going to find the x-intercept by substituting y with 0, and that gives us 2x plus 5 times 0, so that cancels, equals -10, and then we divide both sides by 2, and we get x equals -5. So that means we have a point at -5, 0, and then we're going to find the y-intercept. So we're going to plug in 0 for x, and 5y equals -10. That cancels. We divide both sides by 5, and we get y equals -2. And so we have a point at 0, -2. So here are the 2 points on our graph. But to connect the points like this would be wrong, because this implies that every point on the line makes the inequality a true statement if we were to plug in the x and y value. But we have a greater sign, not a greater than or equal to. So this would be the correct way to plot our line. So if we were to plug in any point on the dotted line, we would find that it does not satisfy this inequality. For example, the point -5, when we plug in and simplify, it says that -10 is greater than -10, which is not true. But we need this line because we're going to see that it separates the points that do work from those that don't. So we're going to pick a point to plug in to the inequality as a test. So the easiest test point we could use is 0, 0. And so we plug that in for x and y, and we're going to find out whether that point makes this inequality true. So this ends up being 0 plus 0 is greater than -10. Since it's true, that tells us that we could pick any other point above the line, and it would also satisfy the inequality. So that means we get to shade in this area, and if we really wanted to be sure, we could pick any point in the shaded area, such as 8, -4. So we'll plug in the point 8, -4. So 2 times 8 plus 5 times -4 greater than -10, and we get 16. 5 times -4, and 16 minus 20 is -4, greater than -10, and that's true. And then we'll plug in 1 point from the unshaded area. We get -36 is greater than 10, and that point makes the statement false, which is what we would expect since that point is not in the shaded area.